Hi again, everybody. Welcome to the fourth video in our Systems of Linear Equations series. Today we're going to look at another algebraic method. We're going to look at the elimination method. So in the elimination method, we eliminate one of the two variables by adding or subtracting the equations in the linear system. We then work with this new equation to determine the value of the variable that remains. It may be necessary to adjust one or both equations in the system for the elimination to occur. Remember, that's our goal with these algebraic systems, to create an equation that instead of having two variables has only one. Okay, let's look at an example. So the first thing I will do is number my equations for organization. Now let's talk about eliminating. In order to eliminate some variables, we need opposite variables or opposite terms to exist. Once there's opposite terms, we can then add the equations and they'll just simply cancel those terms out. So what I'm talking about, in this system, there already are some opposite terms. You can say negative 2y and positive 2y. They're opposites. Now in the future examples, there won't be opposite terms set up for us. We'll need to create that. But for right now, we have opposites already. So what will happen when I add these equations is that the y terms will cancel out. I'll show you that. So here I'm just drawing my kind of page break, if you remember. I'll make a little note for myself. I'm going to add my two equations. So the way I add them is I'm actually just going to add vertically. And I'm just going to add my like terms. So here I go adding. This now cancels out because that's going to be 0. So I get 9x equals 36. Once you have this new smaller equation, you solve for the x, and that'll be the x coordinate in your vertex. Divide by 9, divide by 9, x equals 4. So I've found half my vertex that quickly. Once you have the opposite terms, the method's pretty quick. So my first step will be this elimination, and that allows me to solve. The next thing I'm going to do is, well, there's a choice here. I could start over again and now attempt to eliminate the x's in order to solve for the y. Or I can just actually kind of dip back into substitution method and do the following. I can simply sub x equals 4 into one of these equations. Now I worked with both equations, so it doesn't matter which one I actually work with. So I'll just say equation 1. So I can just say like 4x minus 2y equals 10, and then 4 times whatever my x value is, minus 2y equals 10. My x value is 4 like we talked about. So I get 16 minus 2y equals 10, and now I'm just going to solve for the y. Typically this is what I do, is I do the substitution step. But if you want, like I said, you can just start over again and then now try to eliminate your x's to solve for this y. Depending on the question, you know, one technique might be faster than the other, but overall I like using this version. So I'll eliminate through my addition to find my first coordinate, and the second coordinate I'll just sub in that first coordinate because I think that's pretty straight ahead. So then that's my answer, everyone. My solution set would be 4 and 3. And I can check it if I wish. We've checked in previous videos, but I'll maybe just do a lazier check here where I'm not going to check with both. I'm going to check just with one. So I've already kind of proved it works with equation 1, so let's prove it works with equation 2. 5x plus 2y equals 26. 5 times 4 plus 2 times 3 equals 26. The left side is 20 plus 6 equals 26. So 26 equals 26. So yes, it does check out to give me more proof that that is my answer. Again, you don't have to check ever, but I mean, unless you're asked to check in the question. But checking is smart if you just don't feel comfortable with the question. Let's look at another example. So again, I'm going to number my equations just for organizational purposes. And then now if I check out my terms, there are no terms that are opposite. So I have to create them. It's not tough to create them. Realistically, you just pick the variable that you want to eliminate, and then you just have to make them opposite terms. So I can look at my x's or my y's. Now, the x's are both positive, but my y's are positive and negative. So in my head, they're kind of closer to being opposite already. So I'm going to choose to eliminate the y's. I definitely could eliminate the x's quite easily though too, so it's not like I'm gaining much of an advantage. And then in order to eliminate it, you have to think about the lowest common multiple between the numbers in question. So lowest common multiple, I'm looking at a 7 and a 2. So if I make my list, what would eventually come up is, and I think you know this, would be 14. 14 would be my lowest common multiple. So I want to turn both those y terms into 14, one of them being positive, one of them being negative, however, so they eliminate. And then what I do now is I just multiply each equation by whatever it takes to make 14. So like in this one, I'll have to multiply by 2 because 7 times 2 equals 14. In the second one, I got to multiply by 7 because 2 times 7 equals 14. Okay, so that is going to be my first step, is adjusting these equations. Once they're adjusted, then I can eliminate. So like I said, I'm going to take equation 1, I'm going to times it by 2. And I've already got that set up top there, so I'm just going to write this out. 4x plus 14y equals 48. Once you have a new arrangement, give it a new number, remember. So I'm going to call that equation 3, meaning that equation 1 and equation 3 represent the exact same line. If I graphed both of those lines, I'd only see one because it'd be the same line. Equation 2, I'm going to multiply by 7. So in order to make them opposite, sometimes you'll have to multiply one of them by a positive number and then the other by a negative number. That happens quite often. In this example, my terms are already opposite signs, so I'm allowed, that allows me to multiply by two positive numbers because of the signs are already taken care of. Anyway, I've already got it set up top. So 3x times 7 is 21x, and then minus 14y equals negative 28. New arrangement, new number. Okay. Now I have my elimination ready to go, so I can actually just eliminate. So I'm going to add 3 plus 4, 4x plus 14y equals 48. So I'm just writing out these two lines again. 21x minus 14y equals negative 28. And these will cancel out. 14 minus 14 is 0. So then I end up getting 25x is equal to 20. Divide by 25, divide by 25. X then equals 20 over 25, but I can divide those both by 5s. So I get 4 over 5. Okay? That is the x part of my vertex. So now I will sub that value in. Sub that into. And again, I just worked with equations 3 and 4, so it doesn't really matter. So I'll just say equation 3. Equation 3 is 4 times x plus 14y equals 48. Let's leave room. Let's write this all out. My x value is 4 over 5, so really I should have wrote my 4 as 4 over 1, so I'll change that right there. So now I get 16 over 5 plus 14y equals 48. And again, we don't like working with fractions if we don't have to. So I'll multiply this by 5 and y 5, because by whatever the denominator is. If there's more than one denominator, you have to pick the lowest common multiple of the denominators. But there's only one, so I multiply that by 5. 16 times 5 is 50 and 30. So, oops, let's go back to blue. 80 over 5. Plus that would be 50 and 20. 70y. This will be 240. Very easy, by the way, to like miss a negative sign or something, or miscalculate something. You're kind of worried about the technique, and there's so many little calculations going on. So if you get something wrong, just go back and check your work. It's often such a small detail that's kind of annoying how small the detail is that messes you up. Anyway, 80 divided by 5 ends up being 16. So right away, once you do this trick, when you're multiplying up here, if you only have one fraction, right away you know that that 5 is really going to be canceled out by the 5 that you're multiplying. This 5 here, though, still gets multiplied to the other 2, by the way. But you do have a shortcut if you wish to do that. So 16 plus 70y equals 240. And now I'm just going to solve for this y. So subtract 16, subtract 16. Looks like it's going to be another fraction. 30, so 224. Divide by 70. Divide by 70. Y equals, so that reduces to 112 over 35. Okay, so that is my prospective answer. I could check it. I think that's a good one to check because that just kind of feels like a weird answer, doesn't it? So that's 4 over 5, and this is now 112 over 35. Like, I can totally picture a student getting that answer and thinking, okay, well, that can't be right. So let's check that one just to kind of prove it works out. So I'm going to check it with the other equation, which is equation 4. So I would get 21 over 1 times 4 over 5 minus 14 over 1 times 112 over 35 equals negative 28. That becomes 84 over 5. This, I'm sorry, I got to reduce this. I hate multiplying without reducing first. So if I divide 14 and 35 have a common factor of 7 in common, meaning 7 times 2 makes 14 and 7 times 5 equals 35. So when you notice that, you can divide the common factor out and it doesn't change the question. So if I divide 14 by 7, I get 2. If I divide 35 by 7, I get 5. And then now I can multiply that, and it's just a smaller version, so it's better, especially when you're doing things in your head as much as possible, which I am when I'm doing these videos. Not all the time, I don't want to lie to you guys. Anyway, 84 minus 224, that works out to negative 140 over 5, which equals negative 28. And if I divide negative 140 divided by 5, that actually works out to negative 28. So you can see they match up. So even though that was some weird numbers, that's okay. That happens sometimes. Now imagine trying to do this. Wow, my stylus is all of a sudden all over the place. So sorry that was so messy, everybody. But anyway, back to what I was saying. Imagine trying to do this using the graphing method. There's no way you could graph that by hand, right? You'd have to estimate, and you would never estimate values like that. If you're using graphing technology like a calculator or maybe Desmos, like an internet graphing calculator or visual software, then you could get that answer no problem still. But if you're doing it by hand, graphing method is tough. Okay, so let's do one more. I'm going to be tight for space, so I might not check this one, but you can see what the issue is. We have fractions. So first thing I'm going to do is I'm going to get rid of my fractions. So I'm going to get rid of my fractions first. Then I got to set up my elimination. So I'll have to adjust my terms or my equations again. And then I can finally solve. So this question has a lot of pre-work in a way. I'm going to have lots of different versions flying around, but remember, I'm only ever working with these same two lines. Like visually, it'd just be these two lines in space. So here's equation 1, equation 2. First thing I want to do is get rid of the fractions. So for equation 1, if I check out the denominators, it's 3 and 2, so I know my lowest common multiple of my denominator would be 6. So I multiply everything by 6. 6 over 1 times 2/3 x plus 6 over 1 times 5/2 y equals 6 times 28. So that was equation 1 times 6. So I'll just go through that. Now again, I like reducing. I kind of talked about that before. If you don't like reducing, do your normal multiplication, multiply then reduce. We'll get the same answers. It's just I can do mine a little bit quicker using this technique, and I use up less space, I guess, too, which I don't know if that's really a bonus, guys. It's not a bonus, but Anyway, I'm going to do it in this case. That is 120 and 48, so 168. Okay, so that is my fractionless version. Okay, equation 2, I'm going to have to multiply it by something. So if I check out its denominators, 4 and 8. So the lowest common multiple of that denominator would actually be 8. You could choose 32. You could just multiply it together and you'll get the right answer in the end. You're just going to be using some larger numbers, and I don't think that's the worst either. So multiply by 8. Okay, so I'm going to get 8 over 1 times 3 over 4x. Plus, it's a positive 8 I'm multiplying by. That's why I wrote plus. And then this is negative 1/8 y equals 8 times 8. Okay, and again, I'm going to reduce. So 8 and 4 have a common factor of 4, so I can divide them both by 4. So I get 6x. This will be a negative. I see the 8s have the 8 in common, so I just get 1y. And then that equals 64. So I've done step 1. I've gotten rid of the fractions. Now I have to start caring about setting up my elimination. So within these two lines, I've got to find opposite terms. So I see 4x and 6x. I mean, I can make them into 12s, one of them positive, one of them negative. The 15y and the negative 1y, I could just turn equation 4 into having negative 15y, and then that would be what I could eliminate. So you can eliminate the x's or the y's. I will choose the y's because I only have to adjust one of the equations rather than both. So that's my logic there. So I'm going to do that. I'm going to take equation 4 and I'm going to multiply it by 15. Why 15? Because then that would give me a negative 15y in that equation. That will be the opposite of the positive 15y in equation 3, and that will set up my elimination perfectly. So 15 times 6x, that's a positive 15, times negative 1y equals 15 times 64. So that is going to be 90x minus 15y equaling 960. And I had written that number out before, everybody. I didn't do that in my head. So new arrangement, new number. So that's 5. So again, I have a lot of these numbers, but let's remember up here, 1 is equivalent to 3, and we've adjusted that. 2 is equivalent to 4, which is equivalent to 5. So I really only have 2 lines still. This is one line. These 3 versions represent another line. So I still only have 2 lines being represented. Okay, so now I can eliminate. I'm going to be in tough here to have enough room to finish this question. So to eliminate, I'm going to add equation 3 and 5. And again, you can see I'm 3 right here, 5 right here. I'm always working with one version of each line. I just have different choices to use. Okay, so 4x plus 15y equals 168. And then 90x minus 15y equals 960. Draw my line. I'm going to add that. So these cancel. 94x, 1,128. Divide that by 94. Divide that by 94. And it works out to a nice even number, 12. So it seems like I found x first in a lot of these examples. You can find y first as well. Okay, so I don't want to bias you and think you always got to find x first. You do not need to. Okay, so then once I found that, now I can find my y. So I'm going to sub the value of x equals 12 into any version of what I've worked with, because I worked with both lines there previously. So yeah, whatever you want to. I would avoid equation 1 and 2 because those are the messy fractions, but anything else would work. You know what? I don't want equation 4 to feel left out. I worked with 3 and 5 there, so why don't I work with 4? It's a good equation too, you know. Okay, so 6x minus y equals 64. So it's going to be 6 times whatever the y value, or sorry, x value is, and the x value is 12. So 60 and 12 make 72 minus y equals 64. Kind of break up my room there. So let's write that again. 72 minus y equals, I kind of killed the little amount of space I had here. I'm going to then subtract 72, subtract 72. So negative y equals negative 8 divided by negative 1 divided by negative 1. Y equals positive 8. So then my solution, I'm saying, is 12 and 8. That is the point of intersection between these two lines. All right, a final example. We'll just do one situational problem. I didn't do one of those in the substitution methods because that video was kind of long enough. In this one, it's not as long, so let's do one of these. So remember, when I'm working with this, I'm going to have to define my variables. I'll have to create my system. Then I can solve. And if I wish, I could always check. So those will be the steps I'm going to follow. Now, why am I having to create my own system? Because it wasn't presented for me. Okay. Now, when you are doing this, so I'll keep it kind of color-coded here, variables. The variables, they're always going to represent the unknown quantities. And the unknown quantities, they're always listed in the actual question part. So you can see when I read through this, the first few sentences are just statements and they're pieces of information. I'm going to look for the sentence with the question mark, because then that'll be the actual question. And then we're going to look to see what we're looking for. And actually, I might as well just jump right to that. At the final sentence, it has the question mark. It says, what is the cost of a bag of each type of bulb? So I'm looking for the cost of these bulbs. All right, so Ava and Ethan sold flower bulbs for a school fundraiser. Ava sold 5 bags of tulip bulbs and 2 bags of daffodil bulbs. She raised $80. Ethan sold 1 bag of tulip bulbs and 4 bags of daffodil bulbs. He raised $70. What is the cost of a bag of each type of bulb? So those will be my variables. So that'll be my x and my y. Okay, this will be the cost. It doesn't matter which bulb you put first. I'll say tulip. And this will be cost of daffodil. And I guess I should say bulbs. Okay, so those are my variables. Second step, we want to create that system. So I think I've mentioned it in my previous videos. Often there is no real pattern, but sometimes you have there's one easier equation, then there's one more detailed. Other times there's just like one sentence describes one system and another sentence describes another. Those are the ones that are a little bit easier, and that is how this one is. It talks about Ava right here. Ava sold 5 bags of tulip bulbs and 2 bags of daffodils, and she raised $80. So we know that she sold 5 times whatever the cost of the daffodil bulb or the tulip bulbs, so x, plus 2 bags times whatever the cost of the daffodil bulbs are, and that was going to equal $80. The second, so that would be my first line, my first equation, my linear equation. The second was Ethan. He sold 1 bag of tulip bulbs, so 1x, or just x, and then 4 daffodil bulbs, so then 4 times whatever their cost was, and that worked out to 70. So that is my system that I've created. So now I can solve. Now to solve, you could, in theory, use the graphing method, substitution method, or the elimination method. So we're working on the elimination topic, so we're going to stick with the elimination. On your quiz and test, I'll always provide at least one question where it's your choice, you solve it how you want to. But there will be other questions where I'm telling you how to solve. Anyway, I have to look at my variables. And if I look down here, my terms, I see 5x and 1x. I mean, whenever you have a 1x, it's kind of easy just to multiply that 1x by whatever I need to cancel out. So that one kind of jumps to my eye that If I multiply the second equation by -5, then that would create opposites. But if I look at the y's, I could make that 2y into a -4y by multiplying by -2. So again, whatever you want to do. Now, previously I've solved for a bunch of x's first. So the way I'm doing it right now, I'll solve for a y first, and I'm going to do that just to show you it doesn't matter. But it truly, whichever way you want to go, however you want to start the question, it doesn't matter as long as you're using proper math. You don't have to find the x's first, and you don't have to find the y's first. Just whatever makes sense to you. Let's start. Okay, so I guess I should really number these. I know I have lots of numbering going on now, but these are my number equations. So I'm going to take equation 2, and I'm going to times it by -5, I said. So that it would be -5 times x, and it's a -5, so I write -5 again, times +4y equals -5 times 70. So I get -5x, -20y equaling -350. Okay, new arrangement, so it gets a new number, so that'll be 3. So now I can eliminate. I'm going to add 1 plus 3. So 1 is 5x plus 2y equaling 80. My equation 3 I just wrote down before, so write it down again here quickly. So my x's will cancel because they're opposites. 5 minus 5 is 0. This will be -18y. So that's going to be -270. Now I got to divide that by -18. Now again, it's real world problem. We're looking for costs, so we can't have a negative answer here. When I work that out though, 270 divided by 18, that works out to 15. Meaning it's $15 for a package of the daffodil bulbs. So that is the y's. Now I got to find the x. So I'm going to sub y equals 15 into whichever equation I want to use. I already used 1 and 3. And again, I haven't used 2. It's not like you have to use everything, so don't think that. I just like kind of spreading it around. Reminder, and I kind of liked something I did in my last question, just reminder of the connections, like equation 1 is, it's itself. Equation 2, though, is the same as equation 3, or what I'm trying to say is the same line. So I used 1 and 3 the last time, so I'm just going to use the 2 version of that second line. So that is x plus 4y equals 70. So x plus 4 times 15. Oh, I blew my color coding. That's okay. I think we're likely past that anyway. 4 times 15 is 60, equaling 70. Minus 60, subtract 60, x equals 10. So my solution set would be 10 and 15. But this is a word problem, so you want to answer like with meaning in the question, and you can do that then. So I'm going to kind of use a poor sentence, but tulip bulbs, or packages of tulip bulbs, cost $10, and daffodil bulbs cost $15. All right, so that is everything I got for you with elimination method. Students usually really like elimination method, but there's times that substitution method is easier, makes more sense as well. So there's different methods because there are times when these different methods come in handy. All right, so hopefully that made sense. If it didn't, talk to your teacher or come find me. Otherwise, have a great night, everybody.